Today lecture I will show you how to find adjoint of a 3x3 matrix. So without wasting any time, let's come to our point and find the adjoint of a 3x3 matrix. So I take a 3x3 matrix for which I will do the analysis. Let the matrix is 0 1 0 0 1 0 0 0 1 0 0 1 minus 3 minus 2 minus 5. So this is your 3x3 matrix. For this matrix, first we have to find the cofactors a11, a12. I am giving the subscript 1 1 1 2 1 3 in a sense that the first figure in the subscript indicates the row, and the second figure in the subscript indicate column number. So this is row first, and this is this is column second, and this is also the same row first and column third. So in the same way, this will become a21, a22, a23, a31, a32, a33. So now we are going to find the cofactors a11. So for finding the cofactors a11, a simple technique a11 can be found out as in this matrix. If you compare this matrix with this cofactor matrix, so in the place of a11 in this matrix there is a 0. So expand this matrix by first row or first column. You can expand it. So I first expand it by the first row and first column from 0. So it will becomes I mean that this first row and this first column will be deleted, and the matrix will be left out with us as 0 1 minus 2 minus 5. This is a determinant of a 2x2 matrix. So you know the techniques or you know the ways of how to find the determinant. So determinant can be found out as by multiplying this diagonal elements minus this diagonal elements. So 0 cross minus 5, which is equal to 0, and 0 minus into minus 2. This will be comes out as a11 equal to 2. In the same way, for finding a12, so compare these both matrices. A11 here is 1, so delete those matrix and those columns in which this elements is included. So if you see this matrix, a12 is included, or this one element is included in the first row and the second column. So delete this first row and this second column. So the matrix will be left with us as a12 equal to 0 1 minus 3 minus 5, and this is determinant. So a12 by taking the determinant, we are left with a12 equal to plus 3. So repeat these techniques for finding A13, A21, A22, A23, A31, A32, A33. Let I roughly take these values of A11, A12, A13. A11 here with us is 2 and A12 equal to 3, and I guess A13 to be minus 2, A21 to be minus 1, 4, 6. I am here doing a guess. I am taking these values by a guess because it will take a long time. Here I have done the method I have done for these two cofactors. So you will repeat. So you will just repeat these same techniques for finding the remaining cofactors. This will be 5, 9, and by taking the cofactor signs and by deciding the cofactor signs, you have to compare this estimated, yeah, this matrix with the sign matrix plus minus plus minus plus minus plus minus plus. The logic here in placing sign is if you take start from plus, so the next sign will be different. Let's say if here you place plus a positive sign, so next this sign there will be a different sign. If there is plus sign, so there will be minus sign, and there will also be minus sign. Remember this easy logic, remember this simple logic, that two same signs cannot be placed consecutively. So consecutively different signs will be placed with each other. So this will be left as it is, so it will be left as 2, and here it will this value we will take a minus, a negative value, so this will become minus 3, and this will be left as it is minus 2, or minus minus, it will be plus 1, this will be plus 4. So we are about to finish. Now you have to take the transpose of this matrix. Let I say this matrix to be A, so the transpose of A will be I hope you will know the techniques, or I hope you will know the way of taking the transpose of a matrix. In transpose, we simply convert the row into column and column into a row. So here the row 2 minus 3 minus 2 will become a column 2 minus 3 minus 2, and this second row will become second column 1 4 minus 6 minus 5 9, this will be our third row. So this is your adjoint of 3 cross 3 matrix. So that was all about techniques of finding adjoint of a 3 cross 3 matrix. So see you soon.